We know from our previous studies of simplifying radical expressions that a fraction is not fully simplified if it contains a radical in its denominator. The process of eliminating radicals from the denominators of fractions is called rationalization. And in most cases, rationalizing the denominator of a fraction results in an expression that is much simpler than the original one. And in this video, we're going to talk about the first technique to rationalize denominators of fractions. Specifically, we're going to rationalize denominators that contain a single term square root. In future videos, we'll learn how to rationalize the denominators of fractions that contain more than one term, or higher order roots like cube roots and fourth roots. But in this video, we're going to specifically focus on rationalizing denominators where the denominator is a single term square root. Here we're told to rationalize this denominator, and the fraction we're given is 2 over the square root of 7. This isn't a fully simplified expression because we have a square root in the denominator of a fraction. But anytime we have a single square root in the denominator of a fraction, the process to rationalize that is pretty easy. We're simply going to multiply the numerator and the denominator of that fraction by the square root that's in the denominator. So in this example, we'll multiply the numerator and denominator of this fraction by the square root of 7. That gives us 2 times the square root of 7 in the numerator, and the square root of 7 times the square root of 7 in the denominator. In the denominator, the square root of 7 times the square root of 7 is the square root of 49, and the square root of 49 is 7. So the fully rationalized expression is 2 times the square root of 7 over 7. Notice it's okay for us to have square root expressions in the numerator of a fraction as long as we don't have them in the denominator. Here we need to rationalize the denominator, and the given fraction is 2 over 3 square roots of 5. Here again we have a single term square root in the denominator. Even though the square root has a coefficient, that doesn't matter. We're still going to multiply the top and bottom of the fraction by the square root that's in the denominator. In this case, the square root is the square root of 5. So we multiply the top and bottom of our fraction by the square root of 5 to rationalize. In the numerator, that gives us 2 times the square root of 5. And in the denominator, we have 3 times the square root of 5 times the square root of 5. In the denominator, when we multiply the square root of 5 by the square root of 5, that's the square root of 25, which is 5. Another way to look at this is it's the square root of 5 squared. And anytime we square a square root, the square cancels out the square root because they are opposite operations. Just like adding and subtracting are opposites, multiplying and dividing are opposites. And the operations of taking the square root of an expression and squaring it are opposites. So the square root of 5 squared is just 5. So in our denominator we have 3 times 5. And that gives us 2 times the square root of 5 over 15. Now I want to point this out. Some students might look at this and try to simplify this fraction further by reducing square root of 5 over 15. But we can't do that. Don't make that mistake. So in this case, the only part of this fraction that is eligible to be reduced is the 2 over 15. Because 2 is outside of the root symbol and 15 is outside of the root symbol. But we can't reduce 2/15. So this fraction is already fully simplified. Let's look at this example. Here we're asked to rationalize the denominator. Well, when we look at the denominator, 3x, it doesn't appear that there's a square root in the denominator of this fraction. But we have to remember the division property of radicals. The division property of radicals says that if we have the square root of a fraction, that is equal to the square root of the numerator over the square root of the denominator. Now it's easy to see that we do have a radical in the denominator of our fraction, and we can't just simplify the square root of 3x to get rid of our radical. So here we'll have to rationalize. We'll rationalize by multiplying the top and bottom of the fraction by the square root of 3x. In the numerator, the square root of 17 times the square root of 3x gives us the square root of 17 times 3x. And in the denominator, the square root of 3x times itself is just 3x. And the square root of 17 times 3x in the numerator is equal to the square root of 51x. Again, don't try to simplify this fraction any further, because in the denominator, we only have an expression that's outside of the radical symbol. And in the numerator, we only have an expression that's inside the radical symbol. We will never cancel something inside a radical symbol with something outside of the radical symbol. So this is the fully simplified form of this fraction. Let's do one more example. Let's rationalize the denominator of 14x over the square root of 2. Again, this is a single square root in the denominator of a fraction. So we rationalize it by multiplying the top and bottom of the fraction by the square root of 2. In the numerator, that gives us 14x times the square root of 2. And in the denominator, we have the square root of 2 times the square root of 2, which is 2. Now we might think that we're done here, but because this is still a fraction, we do have to check to make sure the fraction is fully simplified. Remember, we can only reduce numbers outside of the radical symbol with numbers outside of the radical symbol. 14 over 2 reduces to 7 over 1. So this fraction simplifies as 7x times the square root of 2.